Hello and thanks for tuning in. I'm Thomas Elang, member of the Thales Kubernetes as a Service engineering team here in Montreal. Today we're going to talk about a new Kubernetes tool for autoscaling, Keda. What is Keda? Keda stands for Kubernetes Event-Driven Autoscaling. The main advantage of using Kubernetes on the cloud is the ability to manually increase or decrease the number of our application instances. Keda brings this a step further by automatically and dynamically scaling the resources according to custom metrics. With Keda, you have the power to scale your resources according to the metrics that really matters to you. Keda does this in a really easy and intuitive way by already supporting the most common sources with databases like Elasticsearch, Redis, or Azure Cloud Services, or distributed systems like Kafka. On the front page of the website, we can see all the scalers available alongside some tutorial at the end. In reality, Keda works in conjunction with the Kubernetes Horizontal Pod Autoscaler, HPA, external event sources, and the Kubernetes etcd data store. It listens to the external trigger source and exposes rich event data to the HPA in order to scale the pod. But enough talking already, let's see it in action with a use case and a live demonstration. To use Keda with the Thales Kubernetes as a Service platform, you should have subscribed to our service offer Innovate or Industrialize, have a cluster running with a version of elasticity 129 and the DevOps role permissions. To know more about our service, just browse for Kubernetes as a Service Thales, go to our blog, and click on the Get Kubernetes Cluster button. For more details about our service offer, select Kubernetes and Service Offers on the top. A finance company has an application that calculates data. Due to the computation time involved by the process, the application can only handle a certain amount of processes at the same time. The company wants to be able to scale the number of application instances based on the number of HTTP requests received. Keda is the best tool for the scenario, as we wish to scale according to a custom metric. Our application will be running in a Kubernetes deployment. Prometheus is a monitoring solution that will collect the application metrics, including the number of HTTP requests received. These metrics will be displayed in the visualization tool Grafana. Keda will query Prometheus on the request rate and will scale the application whenever the rate increase or decrease by 10 requests per second or more. And finally, we use Vegeta, an open source HTTP load testing tool, to send requests to our application and trigger Keda. Now, on to the live demonstration. Here I have a terminal open, connected to my Kubernetes cluster. I already have Keda and my application running. If we take a closer look at the application, there are two endpoints. The first one, just the root endpoint, is a placeholder that we're going to request, and the slash metrics exposes all the Prometheus metrics, including the request count total, which is the one who interests us, which count the total number of HTTP requests received by the application. In order to tell Keda to scale according to our metrics, we need to use a scaled object. Scaled object is a Kubernetes object specifically designed for Keda. The first important section is the scale target ref, where we specified the target which Keda is going to scale according to the metrics. In our case, it's the deployment of our application. It can be of any kind of Kubernetes resources which implement the /scale sub-resource, like deployment, stateful set, replica set, or any custom resource. Then there's a set of parameters. If we look, for example, at the minimum and the maximum replica count, in our case, we set 1 minimum replica and 10 maximum replica. So Keda can scale up to 10 and down to 1. It's interesting to know that we can set the minimum replica count to 0. In this case, whenever Keda is not triggered, there's no application running, and you can save costs and resources. And last but not least, the trigger. The trigger is really important. This is where we specify where the source of our metrics. In our case, it's the type Prometheus. When we set the Prometheus server address, the metric name we want to watch, so the request count total, and the query, so the sum of the rate of all the HTTP requests for our application over a window of 2 minutes. And finally, the threshold of 10. So whenever the rate increases by 10 or more, Keda will scale up the application by 1 or more. Whenever the rate goes down by 10 or more, Keda will scale down the application by 1 or more. All right, so the scaled object is already installed in my cluster. You can see that it's ready to be used. To use it, we'll use the Vegeta HTTP loading tool. So here's a simple script. We'll just use Vegeta to attack for 2 minutes on send a GET request to our application for a duration of 2 minutes with a rate of 15 requests per second, then 25, then 40, then 60, then 80, then 100 for 6 minutes straight. So let's get this started. Okay, so here Vegeta is starting to work and the application is receiving traffic. We use Grafana, the visualization tool connected to Prometheus, to visualize Prometheus data. Here's the live number of pod of our application running. On the top, we get the total number of HTTP requests sent by our application, measured by the ingress. On the middle, we have the total number of HTTP requests received by pod. Actually, there's none because Vegeta is starting, because we got a window of 2 minutes. So we should be starting to see some data soon. And then there's a pod number according to time. So what we expect to see is the total number of HTTP requests increase. Then the total number of HTTP requests by pod will increase accordingly, and Keda will trigger, and then scale up more pod to according to the number of HTTP requests. All right, I'm gonna fast forward here a little bit. All right, so fast forward 15 minutes later, we can see that the HTTP requests sent by Vegeta gradually increased. The total number of requests by pod increased accordingly. So there is more HTTP requests sent to the first pod existing. Then Keda, when the number of HTTP requests pass the threshold of 10, Keda detects it and then scale another application pod. So when the second pod starts, they share the load, but the HTTP request, the rate of HTTP requests keeps increasing. So the total request by pod keeps increasing too, and then Keda triggers again and scale another one, etc., etc. Till we reach our floor of 100, and then the number of requests by pod finally stabilized with 9 pod running, and Keda stop and they stay at the threshold of 10 but do not cross it, so Keda stay stabilized too, and we get 9 pod running and sharing the load. If we wait a bit, so now we're gonna wait and see what happens when when there's no longer any request sent to the application. What we expect to see is the total request by pod dropping down, but the actual number of pods staying up to 9 for a few times before it actually dropped down to 1, because we set in our scaled object a cooldown period of 120 seconds. So there's 2 minute cooldown in case there's a new load coming, where Keda will stay up to the number of replicas scale up to before scaling down to the required amount. So we're gonna fast forward here for like 3 or 4 minutes. So finally, no more HTTP request was sent by Vegeta. so no more requests were received by the pods, and Keda just waited for the cooldown period, keeping all 9 pods available, and then scaled down back to 1. Let's see one last example scenario together. So we saw what happened if we increase the number of HTTP requests gradually. But what happened if we ask 100 requests, HTTP requests, a burst of 100 HTTP requests to the application for a few minutes straight. So let's send get HTTP request with Vegeta for many times. We're going to stop it manually, and a rate of 100 requests per second to the application. All right, so it is running. So let's see what happened. So here we have the burst of HTTP requests sent by Vegeta. And here we have the total HTTP request by pod. So we have the lot of HTTP requests coming straight to our first pod. Then Keda react really quickly and spawn all 8 other pod. So we reach a total of 9 pod and stabilize around 10 requests per pod. So Keda was able to scale according to a variation of HTTP request, and then a burst of requests really fast and really easily. That concludes our live demonstration. Here are all the key takeaway points. Keda is an open source project originally created by Red Hat and Microsoft. It takes away all the scaling infrastructure and manages everything for you. It's a single-purpose and lightweight component that can be added to any Kubernetes cluster. The Keda metrics server exposes a variety of metrics that can be queried directly using Kubernetes command line or Prometheus. There are about 50 scalers already available within Keda, and it is really easy to create your own. Keda extends Kubernetes functionality without overwriting or duplication. However, as powerful as it can be, Keda is not magical, and selecting the right metrics for your use case is the key to its success. As all horizontal scaler, Keda will scale within the limits of your cluster resources. One of the solutions for it may be to pair it with a Kubernetes autoscaler to dynamically scale more Kubernetes nodes as well. As always, our blog and documentation are available online with more details on our service and our latest features. Thank you so much for watching, and see you next time.